Welcome back to the Geometry Textbook Series. This lesson is written based on Chapter 13, Section 3, Parallel and Perpendicular Lines. Today we are going to learn how to determine whether or not two lines are parallel or perpendicular or neither. And before we get started, you should know how to calculate the slope of a line given 2 points. And you're also going to learn a few new words. Some of those are going to be a throwback. For our warm-up, you need to find the slopes of lines AB and CD given the coordinates provided below. Pause the video, restart when you're ready. I will display the answers in 3, 2, 1 now. Okay, hopefully you can see that AB and CD have the same slope. Now, if this exercise was a struggle for you, you should not move on. You should go back and review Chapter 13, Section 2 before starting the lesson. Now, let's learn about parallel and perpendicular lines. Parallel lines are lines that have the same slope. The following 3 statements are facts. Number 1, line 1 is parallel to line 2 if and only if angle 1 is congruent to angle 2. That comes from our knowledge of parallel lines and transversals. If we treat the x-axis as a transversal, pretty obvious that they are corresponding angles. Number 2, angle 1 is congruent to angle 2 if and only if angle 1 is congruent to angle 2 if and only if the tangent of angle 1 is equal to the tangent of angle 2. Now, this is true just because of the congruency of the angles, right? If both angles are equal, then taking the tangent of each angle should be equal as well. Number 3, the tangent of angle 1 is equal to the tangent of angle 2 if and only if the slope of line 1 is equal to the slope of line 2. Now this is because if we form a right triangle using the x-axis and the parallel line as the hypotenuse, the tangent ratios are only equal if the legs of the right triangles are congruent, which would mean they would need to have the same slope. By the transitive property, it's appropriate for us to conclude that line 1 is parallel to line 2 if and only if the slope of line 1 is equal to the slope of line 2. Now this is true for all lines with a defined slope. Let's formalize what we just learned. Theorem 13.3 states that two non-vertical lines are parallel if and only if their slopes are equal. Therefore, if the slope of line 1 is the slope of line 1 is m1 and the slope of line 2 is m2, then m1 equals m2. Now let's take a look at perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle. Now, like parallel lines, they have slopes that are related in a special way. Theorem 13.4 states that two non-vertical lines are perpendicular if and only if the product of their slope is -1. Therefore, m1 times m2 must equal -1, which also means that m1 is equal to -1 over m2. An easier way to think about that is that the slopes have to be opposite reciprocals. In our one and only example, we're given points S and T and asked to find all lines that are parallel to ST and perpendicular to ST. If you think you have an idea of how to do this, pause the video and resume when you're ready to see the answers. I'll show the answers in 3, 2, 1. Here we go. Okay, so I calculate the slope of ST, which is -1/2. Now, all lines parallel to ST have to have the same slope, so their slope has to be -1/2. Any line perpendicular to ST has to have a slope of -1 over -1/2, which is +2. Remember, opposite reciprocals. Great job today learning about parallel and perpendicular lines. Before we go, turn to your partner and show what you know by determining if the following statement is true or false. If a line is horizontal, then it cannot be parallel to any other lines. Talk to your classmate, and I will see you in the next lesson.